Good evening, guys. Am I audible?
Yes, sir.
Yes, sir.
So yesterday we were discussing the second exercise, right? 8.2. Just a minute, let me open the notes. So tell me one thing, any doubt, any conceptual doubts that you have?
So could you explain again how to find the curve area, sir? For two curves and the circle.
Yeah, I'll definitely. So do you have any specific problem, or you want me to take?
No, in general,
explain
just the
general
concept is
general concept. Okay. Will it be fine if I explain it with an example?
Yes, sir, it's fine.
Okay. So let me. So before, let me wait. Let me share the screen. Yeah. So listen, guys. So if I have to conclude about this chapter, right, it is broken down into three parts. The first part, so main application of integral is to find the area made by the curve with the independent axis. That independent axis can either be x-axis or y-axis. I hope that point is clear, right? Right. That is what the first exercise told me. I think yesterday also you asked me the question, sir, why do we need to do with f of with dx? Why can't we do it with dy?
Yes,
but I hope that point is clear, right? Just clarify.
Yes, sir, that's clear, sir.
That is clear. Okay. Secondly, we will find the area made by the curve with a line. Sharia. So what did we do? See, for example, they ask you a question, find the area made by the line y is equal to x square with the line y is equal to x. Okay. Then this is the area they're expecting. Correct? So this was about the second part of the first exercise. Now, the second exercise is slightly modified. Instead of having one curve and one line, what will happen if you have two curves? Sharia. So when you have two curves like this, what are we supposed to do? So when you talk about two curves, you will be able to find the area between them. You will get a finite area between them only under the circumstance when those two curves are meeting, accepted. So they are supposed to meet, only then you will get a bounded region. Or else it will be an unbounded region. If suppose f of x is like this and g of x is like this, I ask you to calculate the area between these 2 points. Does it make sense? You will not be able to do it. Or what I should do, I should give you those two curves along with two more lines. Then it makes sense. Rohan, are you able to understand what I'm trying to say?
Yes, sir, yes, sir.
Right. Now what has happened is this example that they have considered is a place where those two curves are meeting. So this curve and the other one is meeting on the left hand side at x is equal to a, on the right hand side at x is equal to b. Correct, Ada? Now where this f of x is above and g of x is below. Below what? So if you see from the x-axis, that is, if you have your eye here, if you're seeing from this side, I'm able to say that f of x is at the top and g of x is at the bottom. Correct? Now, what I'm supposed to do is I need to find the area between these two curves. So, area between these two curves. Now, area abdinale integral. Okay. Integral of, now I need to look at both the graphs. So, tell me which graph is in the upper portion, which graph is above. So, integral of, tell me which graph is above.
Y equal to f of x is above.
That is f of x. So this is upper graph minus which graph is at the bottom?
G of x. Sir.
G of x. Both are functions of x only. So you'll integrate it with respect to dx. Now this x will tell you the limits that you're supposed to take. Yeah. So what is the lower limit? It
yes,
is
sir.
A and the upper limit B. This part, if you calculate, you will get the area between two curves. But the challenge is, it's not as simple as I explained it. Because in this case, what we have done, we have taken a generic example, but we saw the problem that we asked yesterday. If you see, find the area of the region bounded between the two parabolas y is equal to x square and y square is equal to x. So what you need to have is, the prerequisite to solve the problems in this chapter is you need to know all the shapes. So tell me one thing, okay? Tell me confidently, because see, I'm asking with the perspective of helping you, not testing you. Tell me one thing, do you know the shape of all the graphs, all the curves that are there?
In the parabolas or including
No,
hyperbola?
parabola, ellipse, hyperbola, everything.
No, sir.
No, right? So what we will do, we will prepare a list. Okay, please write it down. So, equation of curves. So please make a note of this, okay? This you will not find it anywhere. Please write it down. It's a customized version. So equation of curves and their shapes. Okay. So first, if I talk about the line y is equal to x. So if I talk about the line y is equal to x, what is it? It is a straight line passing through origin, correct? And the angle that it makes with respect to x-axis. Tell me guys, how much is it? It is
45 degrees, sir.
45 degrees. Okay. Secondly, you will have y is equal to mx. So y is equal to mx is a graph which will be like this, where the slope of this graph is tan theta is equal to m, or tan inverse of m. Theta is equal to tan inverse of m. This is x-axis, this is y-axis. Correct? This is y is equal to mx. Third, y is equal to mx plus c. X-axis, y-axis. Y is equal to mx plus c is this line, where this point is how much? It is 0, comma c. And the slope of this line is m. Okay. Fourth, x by a plus y by b is equal to 1. For x by a and y by b is equal to 1, the line is like this, where this point is a comma 0 and this point is 0 comma b. You need to be very careful seeing that whether a is positive or negative. If it is if a is negative, then it will come on the left hand side. If b is also negative, that will also come on the left hand side. Depending on that, you need to be wise enough to choose the correct quadrant. Okay.
Yes.
This is all about straight lines. Next is about circles. X square plus y square is equal to a square is what? It is a circle with the center as origin and the radius is a. So this point is 0 comma 0, this point is a comma 0, this point is 0 comma a, and this point is 0 comma minus a, and this point is minus a comma 0. Right? 6. Then you have x square plus y square plus 2g. Okay, this and all will not be asked, don't worry. Let me not complicate it. This is with respect to circle. Then you have y square is equal to 4x. So y square is equal to 4x will be a rightward parabola where a comma 0 is the focus. Okay, and 0 comma 0 is the vertex, x-axis, y-axis. Similarly, y square is equal to minus 4x will be something like this. This point will be minus a comma 0, this point will be 0 comma 0, this point is x-axis, and this is y-axis. Y dash, x dash. Okay. Next, You have x square is equal to 4ay. So x square is equal to 4ay will be a graph like this, where this point is 0, comma a, and it is an upward parabola. Okay. Ninth, x square is equal to minus 4ay. Can someone tell me what will x square is equal to minus 4ay be? It will be a downward parabola with this point as 0, comma minus a, and this point is 0, comma 0. What is that 0, comma minus a called as? It will be the focus. 10th, x square by a square plus y square by b square is equal to 1. If a is greater than b, then it will be a horizontal ellipse, where this point is a comma 0, this point is minus a comma 0, this point is 0 comma b, and this point is 0 comma minus b, and the focus is ae comma 0 and minus ae comma 0. So it will have two foci, or you can call it as foci also. Both mean the same. So x square by a square plus y square by b square is equal to 1. If a is less than b, then this point will be 0 comma b, 0 comma minus b, and this point will be 0 comma b, this point will be a comma 0, and this point will be minus a comma 0. X square by a square plus y square by b square is equal to 1. Okay. Eleventh one is x square by a square minus y square by b square is equal to 1. It will be a hyperbola. This point is a comma 0, this point is minus a comma 0. Generally, they'll not ask you hyperbola because it doesn't form a closed shape. Okay, 12th one is xy is equal to c square is also a hyperbola. It is a rectangular hyperbola like this. So these are all the shapes that we need to know. Okay. Now these are all the possible questions among which they can frame any problem from the areas of integrals. Clear?
Yes, sir.
Now, what we'll do,
So,
we'll
sir,
try
one
to
small doubt, sir.
tell me.
So for all these type of diagrams, you'll just draw a line intersecting it and you'll try say to find the area, sir.
Or I didn't get you, right? I didn't get
So
you. Can
they'll
you
draw a line which intersects these curves and tell us to find an area under anything.
like this, sir? Like this.
Yes, sir. So for each of these diagrams, they'll give a question like
If
this.
they give something like this, I'll tell you the steps that you're supposed. So one major step where many people fail is they expect the boundaries. They will not give you boundaries every time. Okay. So to find the boundaries, what you need to do is you need to solve those two curves. So what do I mean by solving is xy is equal to c square, for example, and the line is y is equal to 2x plus 3. Let's assume something like this. I'll take this 2x plus 3 and substitute it here. You will find the x value. So when you find the x value, right, you will get two values of x. In those two values of x, the least value is the lower limit and the highest value is the upper limit. Clear?
Yes,
So
sir.
then
Yes, sir.
what you need to do is integral of lower limit, upper limit. Okay. Then see, even if it is a line, right? See, line also has a curve. So if you see from this side, When it goes below x-axis, right, see it from the top of x-axis. When you see it from this side, which one is above and which one is below? When you see it from this side, which one is above and which one is below? Is the line above or the curve above?
The curve is above.
No. When you see from this side, means you turn the book and see, no?
The line is above, sir.
Line is above, right? When line is above, right, upper curve minus
Lower curve.
lower curve. So that upper curve need not be a curve always. It can be a line also.
Yes, understood.
Am I clear with the technique of solving it? This is how you think for any problem. Apart from this, there is nothing. This chapter is easy only, provided you understand the basics of it.
Okay, sir,
Right?
understood.
Okay. Just to solve, just for my satisfaction, let's try one more problem. You're going to tell me how to solve. So I thought they will not ask, but they asked. It's better. Write down this one also. X square plus y square plus 2gx plus 2fy plus c is equal to 0. What is this? What is this, guys? I myself slipped. So this is a circle, but the circle is no more an origin. Circle has no, the center is no more an origin. So it is going to be minus g comma minus f, and the radius of the circle will be root of g square plus f square minus c. Clear?
Yes, sir.
It is clear. So the reason I had to explain it is because the current problem that we are going to do is of this format. Okay, if you have made a note, I will proceed there.
Yes, sir. Do a diagram.
Okay. Now see, x square plus y square minus 8x is equal to 0. So if you compare it with the general equation of a circle with the center not being an origin, this is of the form x square plus y square plus 2gx plus 2fy plus c is equal to 0. So this is a circle. And for the circle, where is the center? Where is the center? I just now gave you an idea. Minus g comma minus f. So if I take the coefficient of x to be 2g, then the coefficient of x here is minus 8.
It
So
will be
2g.
4, sir. Minus 4.
So 2g is equal to minus 8. So g is equal to minus 4. But the center is not g, it is minus g. So minus g will be 4. Nothing, that's simple, okay? I'll tell you the logic. Listen. This is from your 11th standard basics, but you saw, right? It's a simple problem which can confuse you. Take the coefficient of x and make it half, 4. If it is a minus sign here, change the sign of it. Okay. Just for the sake of practice. Okay. What will be the center of this circle? Tell me. 12 is there. Make it half. 6.
It will be 6, sir.
But the coefficient of x is positive. Change the sign to opposite.
Yes.
Comma 6.
It will be plus 3. Sir.
It will be 3. So minus 6 comma 3 is going to be the center of this circle. So the last question is 2x square plus 2y square plus 2x plus 4y plus 6 is equal to 0. What is the center?
Minus 1 comma minus 2, sir.
Wrong. It is not minus 1 comma minus 2. I expected that. You can apply that formula only if the coefficient of x square and y square is 1. So to make it 1, what are you supposed to do?
Divide by 2, sir.
Plus x plus 2y plus 3 is equal to 0. So center is?
Minus 1 by 2 comma minus 1, sir.
Very good. Now you understood?
Yes, sir.
Right, all these things you have learned last year. So having this knowledge, so the center of the circle is +4, right? So it is 4, 0. And remember, any equation without a constant will always pass through the origin. So origin is here. If you join them, it will be something like this. Right? Now I gave you certain curves, right? Y square is equal to 4x. What is it?
Rightward parabola.
So it's a rightward parabola. Right. Now find the area lying above x-axis and included between the circle and the parabola. So they're asking which area? This area. Correct? Huh?
Yes, sir.
So from here, if I drop a perpendicular, okay, from here, if I drop a perpendicular, my job is to first solve them. Y square is equal to 4x. I will take this and substitute it here. So x square plus 4x minus 8x is equal to 0. So x square minus 4x is equal to 0. So x into x minus 4 is equal to 0. Correct? Huh? So x is equal to 0 and x is equal to 4. Right? So what is the meaning of this? X is equal to 0 is one line. X is equal to 0 is y-axis. X is equal to 4 is a line parallel to y-axis. So what are the limits? Integral of, tell me the limits.
0 to 4.
Correct. You're integrating with respect to x-axis. So when you're doing with x-axis, what is the upper curve and what is the lower curve?
The
Upper curve
hyperbola
is,
is the upper curve.
check it properly. So when you're doing, see, logic is very simple. If you're doing with respect to first quadrant, see from third quadrant. When you see from this side,
And the
when you
circle
see
is the first equation.
circle is above and parabola is below. So circle equation is root
X
of
square plus y.
8x minus x square. Correct?
Yes, sir.
I took plus because it is a positive quadrant. Minus the lower curve. Lower curve is
2x, 2 root x, sir.
No, integration is your.
Okay, sir.
So root of 8x minus x square means it is not root of a square minus x square. You have to do the completing the square method and then proceed. So yeah, my job is only
Okay,
to teach you how to frame the equations. For this, clear, guys? Anybody having any other doubt? Only one guy is talking to me. Anyone else? You guys are so confident that you can solve any problem. Others are so silent. No doubt.
No doubt, sir. We'll solve and tell if we have any doubt.
That's good. Right. Okay. So you can try out these problems later and reach out to me if you need any help. Right. So other parts I'm leaving it to you. Shall I move on to the next exercise? Next chapter. So miscellaneous also you guys do it. Okay, for the time being. Let me first complete the theory of all the chapters, then I will sit with you guys and solve problems. That is what I thought. Because I don't want to waste time in one chapter itself. Okay, shall I proceed?
Yes, sir.
Good. So the next chapter that we are going to deal is, we have completed 7th, integrals is over. 8, applications of integrals is over. 9th, differential equation is over. Now we are going to deal with vector algebra. So those who are already physics students will have a decent basic of what this vector algebra is. But let me explain it again. Right. So basically, when you talk about different day-to-day physical quantities, for example, you talk about weight, you talk about mass, you talk about you talk about velocity, all these terms are there, right? These are all quantities. So quantities means something which can be measured. You can measure time, you can measure weight, you can measure mass. All these quantities can be measured. So these are all some measurable quantities which are given a common name so that universally it is understood. But if I give you a task where I'm giving you two buckets and asking you to differentiate them, let's say I'm having a small ball on which I've written time. I'm saying put that ball with the name time on it into the right bucket where it is so where the classification is taking place on the basis of two parameters. One of the parameters is magnitude and the second parameter is direction. Okay, so time is a measurable quantity which has a magnitude. Magnitude means a value associated with. You will say time is this much. You will say 4 hours 30 minutes, right? Or you'll say 4:30 p.m. something like that. You will have a measurable quantity. But will you say that the time is 4:30 p.m. in a particular direction, in the north direction, in the east direction, something like that? Wherever you're going to stand, you will say what is time, right? So time is such a measurable quantity which has only magnitude associated with it. Correct? The time is a quantity which has only magnitude associated with it. Similarly, I don't want to get into weight. Similarly, if I talk about speed, let's say you're going in a vehicle and you are trying to see the speedometer, you will say the speed of your particular vehicle is, let's say, 40 kilometers per hour. But you will never say the speed of your vehicle is 14 kilometers per hour in north direction, east direction, or something like that. You never mention direction associated with it, right? So these kind of quantities which have numbers associated with it, that is, numbers are technically called as magnitudes. Okay, quantities which have only magnitude, but we are not concerned about direction, are called as what quantities, guys? They're called as scalar quantities. Whereas there are certain quantities for which there will be magnitude, that is a number associated with it. Along with that number, you will tell the direction also. Okay, for example, if somebody asks you velocity, right? Velocity is a technical name. What is the velocity of car? Velocity and speed has a minor difference, stating that you say velocity of the car is same 40 kilometers per hour, but in northeast direction. You have to mention the direction when you are reporting the concept of velocity to someone. So if you have those kind of quantities, I repeat, if you have those kind of quantities which have magnitude along with direction associated with it, then those kind of quantities are what are called as vectors. And our job in this chapter is to deal with those quantities which have both magnitude and direction. And we will be using the mathematical concept involved in it, that is the algebraic operations involved between vectors. And hence the name of the chapter is vector algebra. Okay, so it is given here. See, in our day-to-day life, we come across many queries such as, what is your height? How should a football player hit the ball to give a pass on to another player of his team? Observe that a possible answer to the first query may be 1.6 meter, a quantity that involves only one value, which is called as magnitude, which is a real number. So such quantities are called as scalar quantities. Similarly, if you have an answer for the second query is a quantity called as force, which involves muscular strength, which is magnitude, and direction. That is the direction in which another player is positioned. So what is the question? The football player should hit in such a way that it is passed on to the other player. So the way he is supposed to pass it depends on the magnitude that is applying along with the direction in which he is supposed to pass it. So force is a quantity that is involved here, which is a vector quantity, which has magnitude and direction. Such quantities are called vectors. So in mathematics, physics, and engineering, we come across with both types of quantity, namely such as scalar quantities, which are length, mass, time, distance, speed, area, volume, temperature, work, money, voltage, density, resistance, etc. And the vector quantities like displacement, velocity, acceleration, force, weight, momentum, electric field intensity, magnetic field intensity, etc. Okay, so in this chapter, we will study some of the basic concepts about vectors, various operations on vectors, and their algebraic and geometric properties. So these two type of properties, when considered together, give a full realization to the concept of vectors and lead to their vital applicability in various areas which are mentioned above. Okay. So is it clear?
Yes, sir.
So listen, the first question is, if I have a quantity called as vector, how do I represent it? Is a question. So suppose let L be any straight line in a plane or three-dimensional space. Let L be a line in a plane. Plane is two-dimensional, three-dimensional is space. This line can be given two directions by means of arrowheads. Okay, a line with one of these directions prescribed is called as a directed line or a vector quantity. That is, if you have a line and you draw that line along with an arrow mark associated with it, which is called as an arrowhead, then these kind of lines are what are called as vector quantities. The line can either be above or it can be below. Then how you write is, the third one, if you see, I'll come to that point. Now observe that if we restrict the line to the line segment AB, so here what is happening in the case of 1 and 2, you're taking it as a line. Line gets extended in both the directions. So line doesn't have a definite length associated with it. So you cannot define the magnitude of it. Correct? So you cannot define the magnitude of a line. But if you want to define the magnitude of a particular line, then you need to take a particular segment of it. And that segment is what we call it as line segment. Right? Then that line segment will have a quantity called as magnitude associated with it. Now, if you observe, if you restrict the line L to the line segment AB, then a magnitude is prescribed on the line L with one of the two directions so that we obtain a directed line segment. So, a small correction, directed line is not a vector, a directed line segment is a vector. Okay, then this line, directed line segment has magnitude as well as a direction. Are you able to understand? So, AB is there. AB is a directed line segment and it has magnitude and direction associated with it. And the other name for the directed line segment is what is called as a vector quantity. So the first definition that we are going to see is, so if you take a quantity that has a magnitude as well as direction associated with it is called as a vector, then how do you write the vector? So the directed line segment is a vector which is denoted by AB, that is the name of the line segment, and you put a bar on top of it. Right? When you put the bar, you should ensure that the bar is going from the starting point to the ending point. That doesn't mean you will write something like this. No. You should always ensure that the arrowhead is towards the right. Okay. So this is how you write AB as a vector. So how you read is, you read it as AB vector or simply A vector. So generally when you write the line segment, right, the notation will be having the letters in caps. But if you replace AB with another quantity, like another variable, if you want a single variable, then that single variable generally will be in lowercase. So AB vector is the same as A vector, which is read as vector AB or vector A bar. Okay. Now, the point A where the vector AB starts is called as the initial point, and the point B where it ends is called as the terminal point. Okay. Generally, we call the initial point as tail and the terminal point as head because it is heading towards something. So mathematics, they are not using, they call it as initial and the terminal point. So the distance between the initial and the final points of the vector is what we call it as magnitude, or in simple terms, we call it as the length of the vector. And the magnitude of a vector is represented like this. You will put the vector symbol on top of it and a modulus around it, or you can simply write it as AB. Right, that is when you write it in the form of line segment, or you can write it as A bar with a modulus around it, or simply A. So the arrow indicates the direction of the vector. So since you're talking about magnitude, the magnitude of a vector can never be 0. So that is the magnitude of a vector being less than 0 doesn't make sense at all. That is what they're trying to say. Is it clear? So this is the basic introduction to vector. Now we understood what is a vector, how do we mathematically represent a vector, and what are all the notations that are followed. Now the question is, how are these vectors classified into different types? Guys, if you're clear, I'll proceed to the next part.
Clear.
Right. So the first important point that you need to verify or you need to know is called as position vector. In mathematics, it is a very, very, very important thing because when you solve a particular problem, you solve everything with respect to a fixed important point called as origin. Right? So with respect to origin, if suppose there is a point P, let us consider a three-dimensional space, and let's say there is a point P which is having the coordinate as x, y, z. So with respect to origin, if you are able to draw a vector like this, means OP with a bar on top of it is a vector. Generally, O is used only for origin. Okay, O is mostly not used for anything. So wherever you see OP bar, OQ bar, OA bar, OB bar, something like this, whichever is starting with O, by default, you can see that the starting point is origin, which is 0, 0, 0. And those vectors whose initial point is origin is what is called as a position vector. Okay. So consider a point P in the space having the coordinates x, y, z with respect to the origin 0, 0, 0. Then the vector OP bar having O and P as its initial and terminal points respectively is called as the position vector of the point P with respect to O. Right. So this is O, this is P. Now, if I want to find the magnitude of OP bar, then what I will do, I find it as root of x square plus y square plus z square. And generally, OP bar is replaced with a symbol R bar. Like how in coordinate geometry you take the general point as x, comma y to find the equation of circle, to find the equation of parabola, all those things. You will consider a point P which is x, comma y, right? Similarly, in the case of vectors, you will take the general vector to be R vector, and that R vector will generally be a position vector. Is there any doubt, guys? Is there any doubt? So direction cosines, I'll explain it in the next chapter. It's not needed as of now. Next are the different types of vectors. So first we saw position vector. The next type of vectors that we are supposed to see are zero vector. So what is zero vector? So zero vector is basically a vector whose magnitude is 0. Means the initial point and the terminal point of that vector is the same. A vector whose initial and the terminal points coincide is called as the zero vector or null vector, and it is represented by the symbol 0 with a bar on top of it. It is not O, it is 0 with a bar on top of it. So zero vector cannot be assigned a definite direction as it doesn't have any magnitude, or alternatively, otherwise, it may be regarded as having any direction. So since you cannot assign direction to it, you can say that zero vector has random direction. So the vectors AA bar, BB bar are called as zero vectors. So you can either write them as zero vector or A and B. They both are the same points. Then AA vector is called as the zero vector. Next is a unit vector. So unit is a word derived from unity. So what is unit vector? A vector whose magnitude is unity. Unity means one unit. If you measure the length of a particular vector and it comes out to be 1 centimeter, 1 millimeter, 1 meter, anything of that sort, if it is 1 unit, then that kind of a vector is called as a unit vector. So there is a slight difference that you need to observe here. The unit vector is generally used to give the direction of any vector A bar. So A vector is there, right? A vector has magnitude and direction. So for unit vector, what you will do is, for giving the direction of any random vector A bar, we use a unit vector. Let me explain what it is. Generally, a unit vector is represented with a symbol like this on top of it, which is actually called as cap or hat. So you read it as A cap. Okay. Now let me explain how it is used to write the direction. Please make a note of it. So if I take A bar, then A is a vector with magnitude. So magnitude of A vector is A vector within a modulus and direction, that is A cap. Clear? So A bar is equal to magnitude of A vector into A cap. So A cap will be equal to A bar divided by magnitude of A bar. This is a very, very, very important formula. You can even treat it like in many problems, we'll have to use this. Sometimes they'll ask you what is the unit vector in the direction of something. At that point, you should know it. And in three-dimensional geometry, this is a very, very important formula because there are two concepts: direction cosines and direction ratios. To do the conversion between those two, you need to know the formula of unit vector. Is it clear, guys?
Yes, sir.
So the next type of vectors are co-initial vectors. Co is same, initial is starting. So if two vectors have the same starting point, then those two vectors are said to be co-initial vectors. Okay. Co-linear. Co is same, linear is straight line. So if two vectors need not be two vectors. If two or more vectors are said to be, so two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. So generally, parallel vectors are also called as collinear vectors. Okay. So listen to this. Condition is, so condition for collinear vector is A bar and B bar can be said to be collinear if A vector is equal to lambda times B vector, where lambda is what? Is some scalar quantity. Okay. Next, equal vectors. Two vectors A bar and B bar are said to be equal if they have the same magnitude and direction regardless of the position of their initial points. So A vector and B vector are said to be equal if they have the same magnitude and direction regardless of the position of their initial points. Means one vector can be like this, another vector can be like this. So their initial point need not be starting from the same location or along the same vertical. But what can happen? These two vectors are still said to be equal if they both have same magnitude and same direction. And the last one is negative of a vector. So a vector whose magnitude is the same as that of a given vector, but in direction it is opposite to it, is said to be negative of a given vector. So AB vector, if it is to the right, then BA vector is said to be negative of AB vector. This is also a very, very important point in solving problems. So if A is the starting point and B is the ending point, then I call it as AB vector. If B is the starting point and A is the ending point, I call it as BA vector. So AB vector and BA vector are negative of each other. Okay. So having said this, we will try to complete the first exercise problems. So example 1, represent graphically a displacement of 40 kilometers, 30 degrees west of south. So there are two things that will come, okay? West of south and southwest. What is the difference between both? West of south or southwest, what is the difference? So southwest means exactly 45 degrees with respect to south and west. But west of south means whatever is a word after south. So starting, right, you're turning towards west by an angle of 30 degrees. That is the meaning. So where to start? You should start along the direction which is there after the word of. So you start from south. From south, you will take a turn towards west. So that's what we call it as 30 degrees west of south. And what do we mean by 40 kilometers? So 40 kilometer, if you take a vector OP, on that OP vector, you will consider a line segment whose length is 40 kilometers. Right. Classify the following measures as scalars and vectors. 5 seconds. Seconds is for time. So it's a scalar quantity.
Scalar.
100 centimeter cube. Centimeter cube is for volume. Volume is
Scalar.
10 Newton. Newton is for force. So force
Vector.
is vector. 30 kilometer per hour. Kilometer per hour, you can call it for speed or velocity. But since they didn't give direction, I'll take it as speed. So since it is speed, it is scalar. 10 gram per centimeter cube. Gram per centimeter cube is density. So density means it is again scalar. 20 meters per second towards south. See, 20 meters per second is again speed only. But towards south is making it velocity. So it is velocity and it is a vector. So in figure 10.5, which of the vectors are collinear? Okay, 10.5 is okay. Which of the vectors are collinear? Collinear means what should happen? They should be along the same line or they can be parallel to each other. So A vector and C vector are collinear and D vector is also collinear with C. So A vector, C vector and D vector are said to be collinear. Which two are equal vectors? So equal vectors means same direction and same magnitude. So A vector and C vector are said to be equal vectors. Which are the co-initial vectors? So co-initial vectors should have the same starting point. So here you have a point and here you have a point. But is this a co-initial vector? Or is this a co-initial? No, because one vector is ending here. They should start at the same point. So this is a co-initial point. So what are they? B vector, C vector, and D vector are said to be co-initial vectors. Right. Now, represent graphically the distance of 40 kilometers, 30 degrees east of north. So I will draw a plane like this: north, east, south, west. So east of north means where should I start with? I just now told. Start with the word which is there after of. So I'll start from north. And from north, I should take a turn of how much value? 30 degrees towards
east.
Yes. So 30 degrees towards east means this is the thing. So 30 degrees. So on this line, I need to consider a line segment whose distance is 40 kilometers. Right. Now, listen. Classify the following measures as scalars and vectors. 10 kilogram. Kilogram is mass. Mass is scalar. Mass is scalar. 2 meters northwest. 2 meters is displacement. Northwest is, 2 meters is distance. Northwest is direction. Distance plus direction is displacement. So displacement is a vector quantity. 40 degrees. Scalar. 40 watt. Watt is for power. Power is scalar. 10 power minus 19 coulomb. Coulomb is for charge. Charge is scalar. 20 meters per second square. It is acceleration. Acceleration is vector. Classify the following as scalar and vector quantity. Time period. Scalar. Distance. Scalar. Force. Vector. Velocity. Work done is scalar. So in the figure 10.6, a square, Identify the following vectors. What are all the co-initial vectors, guys?
A vector and B vector.
Correct. Equal.
A and D and B.
Correct. B vector and D vector. Collinear but not equal.
A and C.
Correct. So answer the following as true or false. A vector and A vector are collinear. Correct? Huh?
Yes, sir.
Yes, they are. Yes. True. Two collinear vectors are always equal in magnitude. A
No.
vector, B vector need not be. Two vectors have same magnitude or collinear.
False.
False, because one vector can be like this, one vector can be like this. This A vector, this B vector, they can still have same magnitude but need not be collinear. False. Two collinear vectors having the same magnitude are equal.
False.
Why?
Direction.
Yes. It's false, because the direction might be different. Right. So this is all about the introduction to the different types of vectors. So the next part that we are supposed to see is addition of vectors and their applications. Okay. So this one I'll start it in the next class, and maximum in 3 more classes I can complete. Sorry, 2 more classes maximum. I'll try it. Okay. So any other doubt from today's class?
No doubt, sir.
No.
Good. So you keep revising it. I'll see you all in the next class.
Thank you.
Thank you, sir.
Thank you, sir.